Welcome to the part of your course that deals with reproduction in small stock. This video will deal with the reproductive cycle of the ewe and the doe. We will be quickly recapping the normal physiology of cyclicity in the ewe and the doe, and then we will deal with factors that may have an influence on their reproductive cycles. The ewe and doe are seasonally polyestrous. This means that they only cycle for a portion of the year, but once they begin cycling, they cycle repeatedly until either 1. They fall pregnant, or 2. The season changes and inputs from their nervous system causes them to stop cycling. They are also spontaneous ovulators. This means that, given good general health, good body condition, season, and maturity, the LH surge which causes ovulation will occur on its own and doesn't need the stimulation of copulation, like we see in cats, for example. The length of the estrous cycle in the ewe is around 17 days, and that of the doe is around 20 to 21 days. This can vary substantially, however. For example, ewes can have a cycle that's as short as 13 days or as long as 19 days. Remember that in the cow, day 0 of the estrous cycle is the day on which the cow stands to be mounted. This is the same in ewes, but ewes are much more shy about expressing signs of estrus and typically give no outward indications that they're on heat. Older ewes might seek out the ram and try to initiate contact. Does aren't much better, but they might exhibit a wagging of the tail when approached by bucks. Estrus in the ewe is usually about 30 hours in duration and about 36 hours in the doe. Ovulation typically occurs around 24 to 36 hours after the start of estrus in both species. Met estrus is usually unremarkable and isn't noticed, and it usually lasts about 2 days and is followed by a diestrus period of 12 to 13 days. Just like in the cow and the mare, we can divide the periods of the estrous cycle into the follicular and the luteal phases. The follicular phases are those in which the estradiol secreting follicles are the dominant structures, and these phases include proestrus and estrus. The luteal phases are those in which the progesterone secreting corpus luteum is dominant. These are late metestrus and diestrus. The following slides will focus on factors that have an effect on the onset of the breeding season and on the expression of estrus in ewes and does. We will break down these factors into seasonal effects, ewe effects, nutritional and managerial factors, the ram effect, as well as the effect of external stresses. The reproductive cycle of the ewe and the doe are heavily influenced by the photoperiod. In contrast to equids, female sheep and goats begin to cycle as the day length shortens. The gestation period of sheep is around 150 days, or 5 months, give or take a few days. Spring and summer are the times of the year that are the most conducive to the raising of lambs. Food is plentiful, and temperatures are usually not too extreme. If we take into account the 5-month pregnancy and work backwards from this, we get some idea of why ewes and does have evolved to start cycling in early autumn as the days get shorter. This then means that the ewe will carry the fetus through the most difficult part of the year, and give birth in spring or early summer. We see a similar pattern among many of our African antelope, for example impala. If you want to see baby antelope, the best time to visit our national parks is in spring. The effect of photoperiod is most marked at higher and lower latitudes. Both the Scottish Highlands and the Falkland Islands are well known for being sheep farming regions. One is fairly far north and the other is very far south. Due to their distance from the equator, there is a substantial variation in photoperiod between summer and winter. During summer, the days are very long, while in winter, the days are very short. If we want to induce cyclicity out of season, we found that the physiological effects of photoperiod are very strong. It's easier to artificially induce out-of-season cyclicity in non-cycling sheep in South Africa than in sheep kept in Norway because of our distance from the equator. One might say that our sheep are in a much shallower anestrus than theirs are. Another factor that can have an influence on the onset of the breeding season is the genotype of the ewe, or in other words, the breed and the strain. Certain breeds are less dependent on photoperiod to induce their cyclicity. This is principally the effect of man's intervention. We've taken sheep and goats with us as we've dispersed around the world, and then selected the ones that have done well in the climates of our new environments. In South Africa, because we have a subtropical climate, we have, either deliberately or inadvertently, selected for animals that perform well and produce more offspring under our conditions. This is why you find that the South African dorper, for example, is far less prone to the effects of season on cyclicity than is the Scottish blackface. As a very general rule, we found that our meat-producing breeds, such as the Dorper and the Pedi, as well as Boer goats, are less influenced by the effect of season on the reproductive cycle than are the wool-producing breeds, for example the Merinos. Younger ewes also tend to display estrus later than older animals, but this is probably principally related to body weight and maturity. We'll discuss this in the next slide. A lactating ewe also tends to start cycling later than a non-lactating ewe. This may be due to physiological lactational anestrus, although this phenomenon is not as well described in ewes as it is in sows and in beef cows. The classic description of lactational anestrus is that FSH secretion is not affected, but that the high levels of cortisol, oxytocin, prolactin and growth hormone may somehow have an inhibitory effect on the GnRH surge center and prevent the LH surge, thereby inhibiting ovulation. Another effect of lactation on the ewe is that it's energetically expensive and forces her to mobilize her body's reserves. The mobilization of fat causes an increase in circulating free fatty acids and a decrease in circulating glucose, insulin, as well as insulin-like growth factor 1. The lactating ewe may be in a significant negative energy balance, which will prevent her from proceeding to estrus by resulting in reduced GnRH pulsatile activity and retarded follicular development. It's very difficult to understate the effect that nutrition has on cyclicity in the ewe. If she is inadequately fed in the period prior to or during the breeding season, or is in a poor body condition, she's unlikely to come into estrus when expected. She's even less likely to ovulate multiple oocytes that will result in the twins and the triplets, which is what really increases the profitability of the wool or the meat farming enterprise. For this reason, a common managerial technique is to flush feed the ewe for at least 3 weeks prior to the breeding season. You may have heard the phrase rising plane of nutrition. Typically this is achieved by significantly increasing the ewe's ration in order to make her body believe that it's entering a time of plenty. Mature ewes usually show a much greater response to flush feeding. The exact mechanism by which flush feeding results in a higher ovulation rate and more lambs is a topic of scientific debate. Some researchers believe that flush feeding directly increases blood glucose, which signals to the ovaries that they should develop more tertiary follicles. Other researchers believe that increased energy causes the pituitary gland to produce more LH, which can cause multiple ovulations. Another theory is that the increased energy available from flush feeding results in a high level of pancreatic insulin secretion, which increases energy uptake and steroid uptake by ovarian tissues. Yet another theory is that high protein in the flush feeding ration increases hepatic enzyme activity, which indirectly results in higher clearance of steroid hormones from circulation, which in turn lowers the negative feedback effects of steroid hormones on gonadotropin secretion. Regardless of the mechanism, flush feeding is a proven way to increase ovulation rate and therefore lambing rate. It works best if the animals are relatively thin prior to flush feeding and are suddenly exposed to a substantial increase in nutrition level. If you flush feed for too long, a situation develops in which the ewe's body almost adapts to this new level of nutrition and her ovaries return to their lower level of oocyte production and she starts to get fat instead of ovulating at a higher level. This isn't a very scientific description of the process of flush feeding, but it does give you a general idea. The presence of a ram can have a substantial effect on the timing of the breeding season and can act as a stimulator of ovulation in cycling animals. This has been called a sociosexual effect. Earlier in the course, when we were discussing the applied physiology of reproduction, we spoke about the hypothalamus and GnRH secretion. Remember that many brain centers have input on the hypothalamus. For example, the pineal gland that regulates seasonality. Social interaction with the ram may also stimulate many of the ewe's brain centers, which in turn have inputs onto her hypothalamus. His appearance, his vocalizations, his behavior, as well as smell and pheromones secreted on his wool and from his infraorbital, inguinal, and interdigital glands can all have a marked effect on cyclicity in the ewe. These work by causing a GnRH surge, which in turn causes the surge secretion of LH, which causes ovulation. This effect, known as the ram effect, can be used in two ways. The first way is that exposure to rams, together with shortening day length, can accelerate the onset of cyclicity, and you can breed your sheep earlier in the year than you might otherwise have been able to. The second way is that sudden exposure of cycling ewes to rams can induce the LH surge and ovulation. This phenomenon is used in certain synchronization protocols, where teaser rams, those are rams that have undergone a vasectomy, are put in a camp with the ewes after using a synchronization product such as a progesterone-impregnated intravaginal sponge, or else a CEDA, controlled internal drug release. The sudden exposure of the ewes to the rams causes a more predictable LH surge in ovulation, which allows for fixed-time insemination. This sort of technique is commonly used for laparoscopic frozen semen insemination, where the lifespan of the sperm is short due to the cryopreservation process that it's subjected to. The term stress can be rather vague and difficult to quantify. What may be stressful for one species is not necessarily stressful for another. Additionally, stress may originate from abnormal social arrangements, poor animal husbandry, poor feeding, and in the case of sheep and goats, by the effects of predation or stock theft. Pregnant ewes may abort, for example, when chased around the field by a pack of feral dogs. The effect of such stress in this situation is relatively easy to identify. It's believed that stress can have a far greater effect on the reproductive system by its effects on the normal functioning of the hypothalamo-pituitary axis and on the regulation of cyclicity. These effects are far more difficult to identify.